Good morning and welcome everyone. I'll give it a few seconds for people to join. But so thankful you all are here, and we'll start soon. Okay, welcome to Driving Breakthroughs in Scientific Research. We are excited to have some great speakers today, and we look forward to your all's participation. I will let you know how to ask questions in a moment, but we are excited for the engagement, so feel free to ask as many questions as you all want. We have some great speakers today. We have Rohan Shakdeva. He is Computational Infrastructure Director at Innovative Genomics Institute at UC Berkeley. We have John White, HPC Systems Engineer at Lawrence Berkeley National Lab. We have George Rath, Systems Infrastructure Lead at Joint Genome Institute. And we have Kyle Lamb, who's Field CTO for HPC here at Vast Data. Thank you all so much for being here today. I look forward to the conversations that you'll have. For questions, you're welcome to ask questions in the Q&A tab. It's going to be on the right-hand side of your screen beside the chat tab. You can ask your questions there. If you want to do it anonymously, feel free to hide your names. We'll probably save a lot of the questions for the end, and if we don't get to your questions, I will have somebody follow up with you personally. So thanks so much again for being here, and I will hand it over to Kyle.
Awesome. Thank you all. So I wanted to go back to the intro slide really quickly. So first off, Rohan, would you mind sharing a little bit about what you do at Computational or Innovative Genomics Institute, and what is the purpose of the organization, and what is your role in specific?
Yeah, sure. So I'm Rohan Sachdeva. I wear two hats here at the Innovative Genomics Institute, or as we call the IGI. I'm our Computational Infrastructure Director, which is a way of saying that I run our HPC system and oversee kind of data flow and processing on those systems. And I am also a research PI. Basically pursuing research to understand microbes using genomic technologies in different environments. And the IGI's mission is to use genomic technologies to affect some outcome that's positive for society, either human health, the environment, or agriculture. And so practically what that means is that we try to use genome editing, usually through a tool called CRISPR, which allows us to make precise changes in different parts of genomes. And so some big examples of this is that recently a lot of news came out that we can basically cure a sickle cell using CRISPR technologies because it can make precise edits in particular locations in genomes. My work is mostly revolves around understanding microbes in different environments, and what we try to do is basically understand the genes of microbes and try to harvest them for different biotechnologies. And so when you go to different environments, most of these microbes can't be cultured, so we have to sequence their genome, so it becomes basically a big data problem. I think that kind of, so that's what we're dealing with is huge amounts of essentially data from these microbial genomes.
Awesome. John, I'm going to ask you the same question for LBNL.
Yeah, so I'm John White. I am the group architect within the science IT group at Lawrence Berkeley Lab. I also serve the same, largely similar role down at UC Berkeley for a very similar program. Some of you may know that LBL hosts NERSC. We are not NERSC. We exist to serve the lab community in a computational platform role. We do the same down at UC Berkeley. So I've been working here for 16 years or so at this point, 14 years at UC Berkeley. We do everything from, we generally host condo compute and condo storage platforms, but we also build bespoke clusters for other customers that have very specific needs within the community.
And speaking of other customers with very specific needs, that's a great segue into George.
Hello, I'm George. I'm a customer with very specific needs. I'm the systems infrastructure lead for the Joint Genome Institute, the JGI as we call it. We do a lot of genomic sequencing for external customers. That's what's it's called a user facility in DOE lingo. And genomics, metabolomics, mass spec, what else do we do? Metagenome sequencing, huge amounts of data, and relatively challenging I/O profiles. So we're partnering with John's team on the one hand for the mid-range compute and the smaller scale stuff, and have like a bespoke cluster for that. And because you mentioned NERSC, which is like an HPC side, we also partner with NERSC for the large scale, really wide computational workloads. Yes, and we try to basically bridge the gap between our scientists who might not have like a computational background and what we can do on the computational side to make their work easier.
Awesome. I'm Kyle Lamb. I'm the field CTO for HPC here at VAST Data. Previous to moving into the field CTO's office, I was SE that actually worked with both George and John on the systems that they have deployed. And so in today's session, wanted to talk a lot about, the things that drove you to look at VAST, how it came about that VAST ended up being a good fit for your use cases. And a little bit about what you like, what you don't like, all of those types of things about VAST, and where we might have some interesting work to do in the future as well. So I'll start off with George, since you were one of the first ones that I talked to on getting a VAST cluster. What drove you towards VAST, and what did it enable for you?
So actually, I remember back because we go a while back by now. John reached out to me and said, "Hey, there is this new company. They're doing flash storage. You want to have a look at this?" And then because the other half of our storage is NetApp, so you can kind of infer how conservative I am, which is very. And the storage system of a cluster that we run is kind of the lifeblood. If that doesn't work, you have a lot of unhappy users, and it's just not a great experience. So we did a lot of benchmarking and validation before we bought the system. Kyle was kind enough to bring me down to their testing side where we ran a few benchmarks. And one of the things that the VAST does really well, I guess we would call it like a pathological workload. There are certain codes that genomics people use that just destroy your raster file system. And we had runtimes of 24 hours plus. And the same workload ran I want to say 30 minutes on the VAST. It was somewhere in that order of magnitude. And that was absolutely great, because if you can decrease the impact of those pathological workloads or challenging workloads, whatever you want to call them, that just leads to a lot of a better user experience. The other things that the VAST does really well, it's like a modern storage stack. So it has a lot of telemetry built in. We make excessive use of the Prometheus monitoring that's there to figure out which user is using what I/O, and if they're doing so much I/O or I/O in a fashion that's not the best for a parallel file system, we can very quickly look at a chart, say, okay, this is our user, and address that. And VAST has absolutely great reporting. So we can run, I think we have 400 or 500 million files in the system now, and you can run a SQL query and say, okay, those are unused files. Those are files that haven't been accessed. Those are files that are probably not necessary to keep on a file system anymore. And we can reach out to our users and do proactive management of the file system. It becomes very unwieldy to manage several hundred terabytes of data, because none of your built-in Unix tools are made to do that.
Yes. And speaking of, I have a chart up about the big catalog, which is, or the vast catalog, which is what you're talking about here, is the SQL queries that you can actually run against the vast cluster. And I'm very happy to hear that you're actually utilizing these tool sets and finding novel ways of utilizing them. I might have you share some of the things that you're doing with it with some of our other customers, because we have a lot of customers who struggle with this same use case, right? Trying to find old data that's stored on the system, or just data that they could actually clean up within the system as well. Rohan, what drove you to VAST, and how did you hear about us as well? Oh, you're on mute, Rohan.
Yeah, so we suffer from a lot of the same issues that George was talking about. Basically, pathological workloads related to genomics, and we're also adding on new kind of capacities in terms of processing cryo-EM data, for example, that just have a huge I/O burden. And so it's always been kind of a long dream of mine to move to a flash-based system, but the cost just never worked out before. So I think that's the first thing that attracted me to VAST, was that we'd be able to do all flash and fit within our budgets. And VAST just kind of came up as one of those main vendors. Beyond that, our previous storage system was kind of a home built system, and so reliability was always a problem. And I wanted to move off of that to something that was properly supported. And where there was monitoring, for example. And so that's something that VAST offers. And yeah, and then kind of another long dream was to have this type of reporting of storage usage. Before, what we would do is do these huge finds of all the files on the system, and we have Python notebooks that go through and calculate all the storage and which users and which folders are storing this data. So being able to see that immediately is important, because sort of the philosophy on our cluster here is we want to make sure the users the scientists, right, don't have to think about managing the data too much in terms of like scratch storage versus, where their data is archived. And so it's a pretty flat system we go for. And being able to know who's using what and tell them, okay, now you need to clean this up, is really a simple thing, right? But was something we didn't think we could do easily.
It's simple until you have to implement it and actually have, millions or hundreds of millions or billions of files that you have to go through, right? That's right. Where it becomes more interesting. Speaking of the costing, I think one of the interesting things that I saw on your system is your data reduction ratio. Mm-hmm. So looking at it right now, or last night anyways, it looks like you're sitting at about 3.3 to 1 data reduction ratio, which means that you can fit 3 times the amount of data in this storage system as you would in another flash-based system that didn't have this kind of data reduction capability. Was that one of the things that drove you towards VAST, or were you aware whenever you were looking at VAST that you would be able to get that kind of a data reduction?
No, I didn't know the exact reduction we would get. I had a little bit of a sense because with ZFS, we were getting about 2x reduction. Okay. So I figured with VAST, we would get more, but we did some tests with the VAST team using, I believe it's called the VAST Probe, on some of our data sets. We weren't able to run it on everything, but just some kind of representative data. And so it looked like we'd get some pretty good returns.
Nice. Okay. John, what brought you and your interest in VAST, and what is the story that you can tell so far?
Yeah, so we're fundamentally coming from a different angle on this than George and Rohan. So we are providing platforms for dozens of labs of similar sizes to the other two. Not to insult or anything. The problems that they mentioned are absolutely there and just magnified. Crawling or getting any sort of metrics on a 10 petabyte Lustre file system is nigh impossible these days. It was impossible 10 years ago for sure. Around 10 years ago, things like Robinhood and these sidecar type of installations that scan your file system once and then desperately try to keep up with change logs that are happening at every microsecond type of thing. They're good. They were filling a purpose, but they're not built right into the platform. That was definitely one of the, and continues to be one of the big features that we really rely on, especially as we start looking towards our next generation of Scratch file system. And which brings me back to why we were looking at VAST in the first place. We've been, we're a mid-range shop very solidly. And All Flash is not in the mid-range yet, at least at scale. It is starting to get there, and we are starting to get a foothold, especially with VAST and a few other vendors. But before that, our home directories, our software module farm, all these little touch points that the second a user logs in, they are interacting with, whether they know it or not, with tab completion or file listings or anything like that, was all spinning disk. There may have been caches here and there, but we all know caches just get blown out when you get to scale immediately. So interactive performance has always been a huge hot button issue for us, and one where we constantly went back to the users, and when they would complain and say, look, this is the best we can do right now without $1 million investment, we're not going to be able to fundamentally change this. But when we saw VAST and we noticed that our enterprise NAS was starting to hit the end of support life, or it was getting real expensive to upgrade and stuff, we realized that there was a pot of money to unlock for this issue. And not only a pot of money to unlock for that issue, but one that places platforms on our infrastructure that let us evaluate it for, what's going to happen 3 years from now when we're replacing other larger file systems. So that was definitely a motivation, and just taking a sledgehammer to the interactive performance problem. And it did that immediately. We do not get those tickets anymore.
Awesome.
The other thing is, a lot of the times we're a traditional HPC shop at our core. We do a lot of extra stuff that we can get into later, but we are an InfiniBand shop and have been for 15 years, or however InfiniBand's been along. We had SDR, and we are now at NDR 400 or 800. So when we talk about our networks to storage vendors, we're constantly saying, do you support InfiniBand? Please tell me you support InfiniBand on the client side. And there are so many that just say no. VAST was the first NAS vendor that we encountered that, like our HPC vendors, understood that this is something that exists. We need to support it, and it's just a first-class citizen. So we plug it into our high-speed network instead of our 1 gig network for provisioning, and we're very happy about that situation.
That makes sense. Awesome. John, I'm going to continue on with you for just a second here, because you also had said some interesting things that you've done in the past with logging, and being that VAST is a multi-protocol storage system, right? Wanted to ask you a little bit about what all you're doing for your logging in the systems, and how VAST has helped you out in that area.
Yeah, so in the area of logging and metrics specifically, this is another thing where 10 years ago, when you looked at the landscape as an administrator, you saw people making these bespoke custom, RRD tool graphs, and they were really nice, and they gave you some insight, but you spent a quarter of your FTE actually building these graphs, maintaining them, watering and feeding them. So we just waited. We had the ability to just wait and kind of hit our 90% target for benchmarking new systems that we knew 90% of our customers would be happy with this. We 5 years ago went back and said, okay, this has to be a solved problem now. And it was, Prometheus existed, Grafana existed, Telegraph, Influx, all these things suddenly existed, Node Exporter, all these. So suddenly we were in a spot where we're like, okay, cool, we'll spin up some VMs and this will be great. And then we start throwing, 6,000 nodes at these systems, at the Prometheus instance and all this stuff. And it's good, but man, some queries take a heck of a long time. So when we got the VAST, we were kind of teetering on the edge of our Prometheus instance, really just about not cutting it. It was still there, but we knew that in a year it was just not going to be able to satisfy all of our needs. So there's this project called Mimir that's a Prometheus backend that can use S3. We were looking at the VAST and saw the S3 over there and just kind of did it, and just to see what would happen. Normally, when you're talking about S3 and Mimir backends and tiering your data within Grafana, you're understanding that if you go for that year view instead of the 5-day view and you click render, it's going to take a while. It's going to have to go to S3. It's going to have to pull these objects. We were not hitting that at all with the VAST. It's just like it's online disk. It is online disk, obviously, but the tiering just is seamless when it comes to that. In addition to that, there's only so much you can throw at a hypervisor cluster before you have to get another block storage vendor or something in there to be able to do reasonably sized storage backends. That the data compression and deduplication we knew was going to have some kind of benefit, but we've been experiencing some pretty great benefit around 7-to-1 or so on the metric side. So our next step is moving away from ancient Unix logging. I am knee deep in that project right now. And one of the main parts of that project or capabilities that we're looking at the VAST in is being able to run some portion of the containerized workload for storage backends of things like ELK stacks directly on the VAST itself. We're really excited about the idea of being able to offload that and not necessarily have to have another touch point where we're just feeding and caring for this bespoke system type of thing. So we're really looking forward to that and being able to slice it off as a tenant so that there's no security concern between the front of house being our user community and our security, folks looking at how we're logging and storing data.
Exactly. Speaking of that, right, we have a data platform that VAST developed, and I'm interested because I know we've already talked a bit about database in the form of, what we're using with the catalog, but I'd be interested if any others are looking at utilizing the database for analytics or things of that nature in the, future term or things of that nature. Rohan, it seems like something that may be beneficial for you all, right? I don't know if the data types that you end up utilizing would be something that having a translation that takes your files and puts them into a queryable database would be beneficial, but I kind of imagine it may be. I'll let you speak.
Yeah, I mean, we're still in the process of moving all our data over to VAST, so we're still getting our feet wet, but that's something that, absolutely being able to query the data with a kind of SQL-like manner will be very powerful for us.
Awesome. George or John, do you have any use cases that you all are looking at?
Well, so I don't, again, as a platform vendor, I just enable the thing and throw it at people and hope that they'll use it. I think we had some early discussions with George, or we are in early discussions that maybe that's an interface we want to expose to the community, but we have not done that.
Yeah, it's the biggest blocker here is our organizational constraints, and I think our people are not ready yet we have massive MySQL databases that will probably benefit from that stuff, but we're just not there yet where we could make a move like that. But one more thing to Prom, the nice thing with the telemetry infrastructure is also John ships the data to us. So we just get the telemetry into our Prometheus infrastructure and we can run queries on top of that, which is also very nice. A lot has been done in that space in the last, I want to say 7 to 10 years. It's absolutely great. S3, I wrote John a message on Slack just now. Yeah, we need to have a look at that for our data, because what S3 offers that POSIX doesn't, because we're like an open science institution, right? One of the big challenges and is that scientists want to share their data, and they want to share their data with another scientist at some other institution. And we're currently using Globus because it's DOE mandated and very fast. But in the modern world, everything now speaks S3, where you could even, not sure if you heard of DuckDB, but there are new database standards where you can point them at an S3 data store and you can run queries on that stuff. And that's very, very exciting. And we're definitely going to have a look at that, where you can, use your HPC cluster to do the data processing on it, and then use S3 to do analysis on it and share the data. That's something that's exciting.
Yes, I hear that quite commonly from a lot of the customer sets, right? The S3 ends up being an easy solution to move data around, right? Whether that's for ingest or whether that's for sharing, both of those work quite well. Interesting discussion point that I had. So at Supercomputing this year, I sat on a panel that was talking about the convergence of HPC and enterprise. And one of the statements that they brought up was that, when looking at, enterprise storage and their HPC storage, I think it was Brown University took a look at how much their Globus transfers were transferring data just between those two storage systems. I believe they said that it was over 40% of their data was just internal migration between their enterprise storage systems and what they were using for HPC. And they looked at VAST and ended up changing over to VAST. And whenever they did that, what they found is, of course, that those two things combined, and they didn't have that data migration issue. They also found some insane data reductions that they were able to get out of the system, right? Because a lot of things were multiple copies of the same data in multiple different places. But they also found that they could actually meet both of those needs, right? Because it is a NAS solution that also happens to be great at doing high performance computing, right? So I was going to ask you all, is that something that seems of interest to you all? Do you have shares that you're sharing out that may be to, more desktop related systems or things of that nature, or have you explored it?
Yeah, so we on the administrative side, we absolutely had that. And in fact, there were some limitations to a number of enterprise NASs we used to have where there wasn't a melding between multiple client networks. So on our existing system, we have our InfiniBands for our clusters, but we also exported NFS and S3 to the rest of the lab over Ethernet. Normally, our global software module farm sits on both sides, but we kept having to do a sync between each one every day. It did save me a significant amount of time suddenly not having to do that. The share is here, it's also here, that's it. In addition, one of the big things we're running into these days is we're trying to figure out what our play is for container orchestration. And when you talk about duplicating data and moving data, that's one point where it's immediately obvious that that's going to be happening. People are going to be processing data on the HPC cluster. They're going to want to make it available in a portal or vice versa somehow. Being able to plumb in the CSI driver for Kubernetes is a huge part of what we're going towards right now. And so removing those touch points of having to do data movement specifically with Globus is really important. But I don't think it's obviously not a silver bullet. Like even within this organization, we have NERSC and we have our systems, and we're never, politically, the networks are never going to be melded. So we do have to still do significant amounts of data movement when it comes to that sort of thing.
That makes sense.
So,
go ahead.
To add to that, we have I've tried doing one storage system for everything in scientific institutions for the duration of my career, which has been about 12 years. And it's always been a bit challenging. If any of you remember Isilon, that was kind of the promise, right? Like with OneFS, and you put everything into one system. And Isilon worked, it was better than the other stuff, but it was very unwieldy. And it was, if you ask me, it just wasn't there yet. Because we've also been part of the EMC Tiger team when the whole thing collapsed, when we actually used it in production. It was interesting times. But anyway, for the user, copying data out of a Lustre system and it seems trivial because you're saying, oh, they just transfer data, but it completely destroys their workflow. It's not, it doesn't make for productive work. Imagine you would sit on your laptop and you need to copy the data onto your laptop, and it's just big enough so that you feel it. It would be torture. Luckily, we have indentured servants, PhD students that are kind of resistant to pain. Not sure how that works, but But if you can take the pain away and like help them to do more science by not copying data around, that works. So we have the VAST, it's serving the HPC cluster, and we have like a big VM infrastructure for portals, serving data. You can think about it as like dashboard that we present to our users, and they can do like analysis on top of that. And that also mounts the VAST, and people don't need to copy data around. And we're talking about like hundreds of terabytes that are usually copied. Like there's a 150 terabyte copy on NERSC, there's a 150 terabyte copy on our like high availability infrastructure, there's a 150 terabyte copy on that other cluster, right? Like if you sum that up, this becomes very costly in addition to being unwieldy. So we're pretty happy with the sharing across enterprise and the HPC space. We needed to be a bit clever on because it's POSIX, right? You need the same UIDs everywhere. That's what John alluded to. You can't do that with like a foreign institution. Maybe S3 can help there, but yeah, the possibilities are endless, and our users love it.
Nice.
Yeah, I'll echo that. I mean, we typically basically use big NAS systems, either many NAS systems or one big one with many disks, to make this all easy for us. So, there isn't a difference between high performance and where you're storing the data. So that made kind of VAST an easy plugin for us because we were able to get the performance and the amount of data, would fit with all the data reduction.
Yeah, and I wanted to go back on one thing. I just suddenly remembered one of the millions of projects going on. Is one we're working for UC Berkeley is, we're like everyone, we're running out of space and cooling. We're spinning up a condo, an extension of our existing cluster down at NASA Ames, from Berkeley down to NASA Ames. It's a wide area link. We got 200 gigs. We're hoping for the best, but we really don't want our customers to be thinking, oh, is my job running at NASA or is my job running at Berkeley? And then having to do affect data movement when it comes to that. So we are, immediately we'll be mounting, just literally routing the NFS down to NASA Ames, and we will have a system down at NASA Ames that will mount up here. We're immediately looking at, what's your product called these days? Constellation?
Data space.
Data space, sorry. I get code names and then I get the production names. So we're immediately looking at situations where there's some sort of automated data staging and data movement between the two institutions, so that when the second a job starts, it starts prefetching data that it thinks is going to be needed to that. Or one of the hopes that we have is that there'll be a Slurm plugin where a slightly more sophisticated user can say, I'm going to be using this data. It'll just immediately start shoving all of the known data down there, start operating it with local speeds, and then slowly feed back as it needs to, if it needs to. We haven't received those systems yet, but we are really hoping for a lot from that functionality.
Awesome. And the good news, John, is that the pre-stage is actually already implemented. So that is something that you should be able to test out as soon as you get your systems in place. You said something else that I just wanted to talk to you all about as well, which is that, you have Slurm schedulers, you have jobs that are running, those types of things. We do support job ID metrics within VAST. It will be something that is in our web UI as of the next release that's coming out, but it's available today. And this will actually work for any NFS file system that you have. It's basically just adding in a little bit of a software package on the nodes, monitors what's going on and reports that back. For VAST, it will implement that into our database. But you can also use it via a Prometheus exporter if you wanted to go ahead and get that exported out today and utilize it both for VAST, but also for any other NFS storage systems that you have as well. So correlating between what jobs are running and who's using resources within the system is something that we're able to do now as well.
So you're going to send us that link?
I will send you that link.
Thank you, Kyle.
Yes.
Please do, yeah.
Yes, it's pretty nice. So John, I was going to ask you also about, a condo model and what you utilize within a condo model and what you envision in a condo model. I have this little slide that kind of just shows a lot of different use cases that we have within VAST, and also shows that you can, expand systems over time and add gear to it as you need more space or more performance, those types of things. And so is this something that matches kind of your envisionment? I think the only thing that we run into is our chunk sizes are much larger than the chunk sizes that you would typically want to be able to offer up to your customers. But otherwise, is that something that kind of matches what your thought process is?
Yeah, so just a background on we've had a very successful condo model for storage side over the last 4 years or so. We're a luster shop. We have enjoyed a relationship with a vendor that lets us purchase 40 disk drive packs essentially. And so we buy the sheet metal, we buy the networking, we buy the controllers, we buy all the flash tier and the metadata, and we sell these 40 drive packs to our customers. At UC Berkeley, they can subdivide that just because of the color of money type of problems. It's hard at Berkeley to be able to do that, but we can subdivide into 4 chunks for that. So it's been very successful. A customer comes to us and says, I need 3 chunks of 112 terabytes usable space, and we give it to them, and they have it for 5 years. Honestly, we run it for longer than that, but we promised them 5 years. And importantly, in our space, they are able to spend that money immediately and get those 5 years. In the research academic space, it's very important that you be able to harness money flowing when it flows, because later on it's not going to flow. So we obviously, it's been wildly successful. We've purchased like 8 extra 90 drive JBODs just for this business type of thing. For us, that's a fair scale. So being able to satisfy that need on the VAST side is something we're still kind of working on. On the UC Berkeley side, I can see it actually working very well, just because, like I said, we can subdivide and pool money together to do a larger chunk purchase. And the flip side of that is, and I like putting the sales folks on the spot here. What we do like doing is VAST tends to offer the ability to throw hardware on the floor and then license the capacity we need over time. And they've been very our sales folks have been very flexible about what exactly that means. But I can certainly see or am envisioning and counting on a future where we are buying a number of D boxes, the JBOS, and saying to our customers, here is the licensing cost all in for a 5-year amount of this support. Then we can grow that over time. We don't need to worry about suddenly falling off a cliff and saying, oh God, we need to put a new order. We can just kind of roll with it and predict when we're going to need more. And if it sits on the floor, that's not my problem. That's the business side, sales side problem to deal with. So the finances of flash are still pretty hard to figure out here when comparing to disk, but they're quickly plummeting and getting to a place where we provide external archival data storage style infrastructures that sit alongside this, where we can kind of meld those two worlds.
Nice. So would you all have any input for your peers? Things that you would say are, the things that peers should look at with regards to VAST, whether that be helpful hints about utilizing the database or big catalog or things of that nature, or other things that you found as you utilized VAST? I'm
sure George is going to echo this, but actually, he doesn't get access to the web UI. If he had access to the web UI, he would certainly.
I do. I have access now.
Oh, I gave you. Okay. Well,
yes.
One of the most useful things in the web UI, honestly, is the Data Capacity Explorer. Like I said before, Lustre is a minefield when it comes to actually, you're not going to do a DU on your top level directory to see who's doing what. It's just there, and you can click and drill down and get useful reporting on people's actual capacity usage. That may seem like a small thing, but when you get to scale, it's just not. That and, again, the web UI, being able to see the traffic flow, you can actually see what CNode is getting exact amounts of network traffic, where it's directing that traffic to D nodes in particular. You can find hotspots. You can see what users are the ones that are driving that, especially I imagine job ITs are going to be integrated with that as well. That's just huge insight analytics that you do not have, or you have to build and spend a lot of time doing on other systems.
Yeah, and the really cool thing, because I mentioned it's like a modern stack, like the web UI has an API, because the front end of the web UI is talking to an API on the VAST, so you can use that API, and we're actually doing that, like this Capacity Explorer thing, we can drill in to who's using what, and instantly we expose that to our users by having a command line tool where you can say, in this path, basically a quick DF, in this path, how much am I using? And it goes to the VAST API, gets the data and relies it instantly to the user, which for us was very little plumbing, and it leads to great results.
Nice.
Yeah, and I think on the kind of web UI side, I lump in monitoring with that too, and that's been something when I think about budgets, right? That now we don't have to think about staff that we'd have to have dedicated for monitoring a lot of this storage. So, I get messages now about when something's down, a node is down, or we're hitting storage capacity, right? And so that puts it off our plate. I don't even have to think about, kind of managing a person to make sure that that's being kept on top of. So that's been really nice.
Yeah, just to echo that a bit, the one of the big problems we have as a platform provider in the HPC space has always been finding a storage person. Sorry, I not tooting my own horn, but 20 years of storage experience is not something that just comes along. And if I had to start now training someone, getting someone interested in storage and taking and holding the bag for potential catastrophe is one thing, but then training them up over years on, Lustre and stuff like that is really a daunting task. But now I'm able to say here, and again, we haven't gone into the scratch space yet, so I don't want to overpromise anything here, but, being able to point my other FTEs in the group and say, start learning this thing. It's not a huge daunting thing. You're going to find a little edge cases here and there, but nothing like you need to build up with Lustre or GPFS or something like that has been a very big thing for us.
Nice. That makes sense. Any other comments that you all would like to add before we start looking at questions? And I don't know if we have Q&A questions or not, but anything else that you all would like to add? Here, I'll actually ask you all this one, since it's one of the questions from the Q&A. It was the question about experience with maintenance, downtimes, upgrades regarding VAST.
So George doesn't do his upgrades. I do George's upgrades. This is one where I'm trying to not be rosy about everything here, but this is not the subject to not be rosy about. Again, harping on Lustre, harping on GPFS, to an extent, other vendors, upgrades are painful. Upgrades are always painful. You deal with legacy systems that have upgrades that have, 20, 25 years of history in how the machinations and everything. Working with what is a fairly greenfield architecture has been really enjoyable. Everything is containerized to an extent. Everything is containerized. You click a button. Sometimes your hardware validation does fail, if I gotta say something negative about it, but you fix your hardware validation and then you click the button again. And then over the next 3 hours, or depending on your system size, you just see containers go up and down and up and down and up and down. You don't lose access to your data at the time. We've had excellent experience when it comes to the upgrades on the VAST. So George largely doesn't know that I'm doing them half the time.
Yeah, so I think that's the testimonial, right? Because I don't know when updates are happening, and I would know because we have very sensitive users. So yeah, it works great. Also, I think there's a question about expanding, adding nodes.
Yeah.
In the beginning of the lifetime of the system, we had a D box, like one of the storage boxes, and one of the front end boxes, and we added another front end box, and that was absolutely like a walk in the park. I mean, from my vantage point, because John did it, John, if you have like
It wasn't turnkey, but it was better than a lot of other vendors. And most of the difficulty is the initial system configuration for a C node isn't necessarily upfront. There is documentation you have to follow on that, and there are some INI files that you do get pretty intimate with when you're doing this sort of thing.
Yeah. Some of that has improved over time as well, but yes, whenever we did especially for the system that we did for JGI, it was early days and it was a little bit more clunky, but it's gotten better in that sense. The nice thing is that all of those additions to the system have all been while it's online as well, right? And so it's kind of a nice thing to be able to just add additional resources to the cluster as it goes and be able to utilize it. So this one is a little bit of a landmine, but I'm going to throw it out there. One of the people asked, how is VAST better than other competitors like Weka, DDN, Exascaler, and are there benchmarks? So I will let you all answer. I have plenty of other sites that I can talk about as well, but coming from your voices, it will sound much better than from mine anyways.
So, I mean, I mentioned in the beginning, right? We did the benchmarks, comparing the system that we compared to Veloster systems. I think it was DDN. I'm not sure on that, right? Like, performance is great. I do have to say our use case is extremely read heavy, right? Like, probably have different outcomes if you need to do a lot of writes, but a workload on the read heavy stuff, it's absolutely great.
Yeah, and I think on our end, it was a specific use case in the sense that we were on spinning disk NAS type system. So going to anything flash storage was going to be better. And just based on budgets, right, VAST came ahead. We looked at Weka, for example, and it just wouldn't work out. And on top of that, because we were kind of already in this NAS type infrastructure, VAST was a easy plug-in for that.
So I'm going to try to be brief on this. I have a lot of experience with all of this. We're a broad workload environment. We handle everything. Prior to having data analytics, we would just, like everyone else, just shoot for the 80% and hope for the best. That specifically left out these two individuals from any workload that we tried to optimize for. Small file genomics just murdered. We would never be able to handle it. We would have to make a bespoke system for them, sort of thing. So that's one of the places where it's just as silver bullety as we can get for that. What I will say though is when we were shooting for that other 90%, that other 90% being including things like large strided writes. Large strided writes is still a problem. It's not a problem in that our workloads are very read heavy. I think it was a shock 10 years ago for a lot of the centers to actually get the analytics and look at their workloads and say, my God, there's only like 20% writes on this. We thought it was completely different. That said, you know, the improvements VAST has been making year over year and even, you know, quarter over quarter on the write improvement has been very heartening to see. Lustre is still going to beat them on the large strided writes when you're doing this sort of thing. That gap is closing very quick. Weka is an interesting one where we have Weka on site. We use them for our Kubernetes installation. We have them on the floor as a competitor just to do a bake-off among Exascaler, VAST, and Weka for the next generation. I would say that the administrative side for the Weka has been more hair-pulling than the VAST. Their performance is pretty great as far as an all-flash goes. They plateau pretty well. You know, when you're designing a system, you want to make sure that your performance plateaus instead of at high thread count starts tanking. That they've held up very well to that is what I would say. But again, it's like Rohan said, the cost competitiveness has been a little difficult on the small end. Once you scale up, they get a lot more competitive. But if you're a mid-range site looking for an 8-node cluster, it's hard to price that out.
Nice. I would say one of my findings that I've seen is just that, and this kind of matches what you all are saying, right? What I found is that VAST does really well whenever you have a lot of different IOs that are going on within the system. What I say is that VAST was kind of designed for a chaotic workflow, right? For the expectation that we're going to have lots of different users running very different IO patterns at the same time. So VAST was never designed to just do, large streaming reads or writes. It was designed more to be able to handle those, but in addition, not optimize for them, but actually be optimized towards chaos, right? Be able to have everything running at once, be able to expect all of that to happen and actually perform well, right? So sometimes an interesting one is that like our random read performance might be better than our sequential read, right? It really kind of hurts people's brains whenever I say that, whenever they're used to a hard drive based system. But whenever you have an all flash storage system and you have it designed with lots of buffers, it actually can get better performance by having random than sequential. So another question here is, does anyone have multiple VAST deployments and they're using replication? So I know John has lots of deployments and replications on the list, but go ahead.
Yeah, we have we have a number of installations. It's kind of scary how fast that happened. So I think we have 1, 2, 3, 4, maybe 5 at this point. And we're getting 2 more, something like that. We do not use replication at this moment, but it was in the RFP for the 2 systems I said that are coming. It is going to be, it was if not the deciding factor when it came to deciding between a couple different vendors, that there was a multi-site replication capability. And like I said earlier, that's going to be a very important part. So if it doesn't work, we are absolutely just going to rake Kyle and folks over the coals until it does work. And to the credit, like when you hire the entire industry away from other competitors, you're able to do those sorts of things very quickly and get them addressed when you have problems. So we're pretty confident.
Yes. Support experiences so far, speaking of?
Let me speak to that because first, everything runs through Slack. There is no ticketing system, which makes me very happy. We had an edge case last year where I had to do with NFS or NFS semantics. And if you open a file and delete the directory, the file still stays open and you can read and write from that. Anyway, I'm going to spare you the details, but we hit like an issue there where one of our bio softwares was doing that. And we discovered that like 6 months in, so you kind of get a feeling of how much stuff is happening in the genomic space where you don't discover things like this. But from looking at the problem, getting a reproducer, working on Slack with the VAST engineering directly on getting to them what they need and like how they can reproduce this issue. And I think it was in a production release, I want to say 2 or 3 months later. Try that with any other storage vendor. Like, it's the speed that the engineering happens is pretty great from my vantage point. And the support using Slack, you shoot a question into Slack, you get an answer like very quickly. It's absolutely great. Also, I should mention, none of us are paid for being here because we sound so like. I'm not sure if you've ever heard somebody talk positively about a storage system that much, but yeah, that's the way it is.
Yeah, I mean, I consider storage probably the hardest part of all of this, of running a cluster. And so, yeah, I think it's been positive so far. And on the support end, having Slack is huge. It's still pretty amazing that I just ask a question there and somebody picks it up. The person assigned to us from VAST, Andrew Stack, has been really great and sort of keeps up with everything that goes on with our cluster. And we have monthly check-ins with him. And so, yeah, it's all been very positive so far.
Cool.
Yeah, I'd never run a Slack myself for customers, but it's nice being a customer that has Slack access.
Yeah. And so a couple more questions that are coming in here. Let me see here. Does VAST have SAN solutions? We do have a block driver that's coming out for our next release, so that will be out by March timeframe. It'll be NVMe over TCP. One question here: how big are environments you're running in terms of terabits per second and IOPS?
Let me see. So we have a petabyte physical, and we're currently doing, but we're doing around like, I think tops it was like 6 gigs per second and 150,000 to like 200,000 IOPS.
Nice.
Yeah, across our other systems, we're not on Scratchspace for our big one, which is it's similar. It's a petabyte, but a petabyte and like 16 C nodes. But it's just serving middling performance, just as far as the draw goes. On the genomics side, we have a customer at UC Berkeley that does pretty consistent bursting around 100 gigabyte a second on, I think they have a petabyte, but they have a weird sales agreement, and across another 16 C nodes for that. But that's across 4 D boxes as well, so they have the different model.
Yeah. And one more question: any benchmarks around HPC environment of VAST versus Pure? I don't know if any of you have Pure.
Sorry, you go.
Okay, so we do have Pure, but we use it in a VMware environment. We have no benchmark that does a like for like kind of comparison.
Yeah, likewise. I think Pure was, I don't think the cost was there, and they don't really cater to the use case.
Yeah. And they don't have InfiniBand. That's the one that I always hit them with.
Yeah, I mean, one of those days you're going to see the light about Ethernet, but I'll hold my breath.
Yes. And that's the thing. It's the nature of a condo environment. If you get into it 10 years ago, you got to keep rolling and rolling and rolling until you cut it off and have a huge expenditure. So that's where we are.
That makes sense. I think we've covered all of the questions. Anything else that anybody would like to share? We're getting close to time here anyways. I will share as far as scale and as far as performance, we do have other HPC sites that are running at much larger scale. They're using VAST as a scratch space. And we have some systems that will be getting deployed here soon, which I'm very excited about, that will be, in the terabytes per second type of performance ranges. So keep your eyes peeled and stay tuned. We'll be sharing lots of details on those as we're allowed to.
Thank you so much, everyone, for being here. I really appreciate it. It was a great conversation, and I love all of the engagement from all of you. For next steps, if you want to learn more about VAST, you're welcome to join our live demos. They happen every Tuesday or Thursday. Just go to vastdata.com/demo. You can always email us questions if you think of something after at hello@vastdata. So again, I appreciate all of our speakers for being here. Thank you all again so much. And to all of our attendees, have a great day.
Thank you all.